So with
Thanks
that,
for the
we'll
introduction,
kick it off.
Chris. Thanks for the introduction. I appreciate being here. Glad to have folks with us this evening, and that's a good summary of the overall situation, and is a nice stepping off point for issues related to agriculture. We're getting wetter, right? So rain makes grain, so that's a good thing. Well, not so directly. So we're going to talk about some of those things. Going to talk about some of the changes in temperature, some other changes that are secondary beyond this, and then some downstream impacts in the way of what's happening with agriculture related to this. And we'll do this all in 20 minutes or so, maybe 30 minutes. So um, first question. This what weather issue or weather climate issue is concerning you most currently? Just what's on your mind right now of what's bothering you? Go ahead and put that in the chat, and you can do that while I get my slides set up here and make sure we are ready to go. Okay, we got a quick one on drought. That's great. And while you're doing that, just a little more about me. I am originally an Iowan, and spent a good portion of my life here in Iowa and going back and forth between Iowa and South Dakota. I got my master's at South Dakota School of Mines and Meteorology, and then I was the South Dakota state climatologist for 13 years, and often came over to your area because it was fairly close for us. So, okay, good questions, good answers coming in here. Asynchronous systems, seasonal flooding, um, nutrient loss from erosion from extreme rain events, good one. Insects, diseases, soil deterioration. Okay, you've covered my whole talk. I don't need to go any further than this. You've done it all. Okay, this is great. This is really great. So very good. So a little bit more, I'm the director of the USDA Midwest Climate Hub in Ames, Iowa. Minnesota is part of our region. I'll talk more about that here. Unpredictably, and I hate hot weather. Okay, sorry, Margaret, personal opinions are not allowed here. That's okay. But heat is a concern. It's a problem, a part of what we have here. So, okay, I'm going to leave I got the chat window open. Can you see my slides, Chris? Are we okay? Are we good?
Yep, we're good.
Okay. All right. Let's dig at it here. And okay, how to mitigate and adapt. Okay, and reducing greenhouse gases. Boy, Jane. That's a whole other topic. That's a whole other set of slides that we need to deal with. And let's hold that and let's talk about that at the end. Make sure we come back and get that. Okay, briefly background on the climate hubs and what they are. They are part of USDA. That was established in 2014 during the Obama administration at a period in time when different federal agencies were being directed to deal with how are we doing with climate change in their areas. And oddly enough, USDA did not have much in the way of weather and climate expertise. There were a few folks only, and there was not a lot of great expertise. So we are in a situation, they spun up these hubs. There are 10 of them nationally, and their job initially was climate change in agriculture, deal with climate change in agriculture. Since then, we have expanded a little bit to a wider range of scales of temperature, of various issues of climate and agriculture, drought, those kinds of things. So those are all part of what we do. So we have an 8-state region here. Let me get my, oh, pointer. Here we go. 8-state region, your area down to Missouri, over to Michigan and Ohio. We do cross borders where we need to work with our partners. You are very close to the Northern Plains Hub, which is based out of Fort Collins, Colorado. And I was also telling Chris before we started, if we get into forestry types of issues, we also get the advantage of being covered by a second hub called the Northern Forests Hub. And they cover our region in the Midwest and the Northeast on the Forest Service side of the house. So deal with forestry type issues. So anything about the large scale trees, go to them. Rest of ag comes to me here where we are in our region. We deal with a wide variety of crops. One of the things I was asking Chris before we started was what crops were in the area, because we try to touch on them all at least somewhat. Um, while corn and beans are a big area, a big production emphasis in our region, there are a lot of other crops in our region. A good portion of the cranberries in the country come from Wisconsin. 85, 90% of the canned pumpkin in the country comes from central Illinois. And then there are lots of tree fruits and other specialty crops, especially focused in Michigan. But then up in your area too, there are a number of these. So, and these crops have a different set of issues than corn and soybeans do, because they're even more affected by weather in certain ways. We work a ton with partnerships. We are a fairly small shop. We're quite a small shop right now. We won't dive into that too much right now, but we work with partners. So situations like this, Minnesota Extension, University of Minnesota, whoever, and other NRC or other USDA entities, we try to work with in what we're trying to develop. So that's just a quick background on just generally about what we are. If we want to ask more questions and talk more about that later, we can go on. So let's start digging into some of the issues related to climate change and ag. Okay, let me ask another question before we go into this here. Put in the chat if you are involved in agriculture, something related to agriculture, or something else. I'm just curious how many folks are directly related to agriculture here, or how many are involved in something else. We're not looking to call anybody out. I'm just curious what people's background is here. Something else. Okay. All right. Yep. Ag research. Okay. And the other part about this, an artist, I love that. I love that. Um, Now, I keep wanting to get off on other stories and won't keep doing that. So thanks for sharing that. Okay. And even if you're not directly involved in agriculture, the interaction of our other natural resources with agriculture is part of what's going on. And agriculture is a big background of what we're doing here. So, okay, let's dive into some of the issues we're looking at here. Just another reminder about what has changed in the way of precipitation. This is from the National Climate Assessment. The last National Climate Assessment that was released in this was the science background of released in 2017, I'm losing track of my years at this point. And basically showing that same kind of thing. The areas that are in green are showing increases in precipitation. So all the upper Midwest, Minnesota's not alone. The other states around are seeing very similar types of patterns, increases of precipitation. That seasonality of that precipitation is the big issue when we get into agriculture. Big events are part of it, but also the seasonality of when that precipitation is occurring is another part of that. And that those are broken down below: winter, spring, summer, and fall precipitation. And it's these increases in spring and fall precipitation that are real problems for us because of what the condition of soils are like and what the conditions of fields are like at that point. Here's another look at that. Now, this is another. I'll share the link with you about the National Climate Assessment later on. This is another place where you can find local information. I'm going to show another plot of this even more locally, but this is a summary of what I call off-season precipitation. Basically, from the fall to the spring, precipitation outside the main part of the growing season. And this graphic shows from 1895 on the left to the present on the right. Each one of the green dots is a year. The green lines connect the dots. The red line is a running average, and then the blue line is an overall trend. So showing you that we have more and more off-season precipitation, and we have few years where we don't have much precipitation away from the growing season, and many more years where we have a lot of precipitation in that off-season. And that's a real problem for a number of different reasons, because one, that's when people are trying to do harvesting or planting. And if you're getting a lot of precipitation, that slows that process down. And especially in the springtime, what's the condition of the soil in the springtime? You don't have a crop growing there in a lot of cases. And if rain hits that, what's going to happen? Well, you're going to get runoff in that situation. And so let's go ahead and jump ahead. And unfortunately, this picture on the right is, an extreme example, but we see too much of this. So because of these off-season precipitation or amounts, we're seeing more nutrient and soil loss potential. And someone mentioned that because of a couple things. One, you don't have a crop growing. If you've done tillage, it's even worse that you've got exposed soil that is exposed to these larger off-season precipitation events. And that leads to loss of topsoil. And that loss of topsoil is a huge issue. In addition to that, you oftentimes, if you fall applied nitrogen, or even in the spring, if you've done some nutrient application and you have big precipitation events after that, um, that's going to be flushed out of the soil and you're losing that into local streams. That's not something that probably captures enough attention in the conversation right now. We get lots of attention about the soils part of it, but we know the nutrient issues are out there. And in some cases, it's not necessarily that producers are doing things that they haven't done before. It's that some of the management schemes or the management the way we manage nutrients maybe used to work don't work anymore because things are changing. So those are issues that we're kind of dealing with. Um, Also, wetness during these times of years compacts soils. For some of us, that's not an issue. For an agricultural system, that is a huge issue, and that is a big loss of potential production. And we talk after the remember 2019, the extreme wet year, and spring of 2019, how much was put in, how much agricultural production was put in very wet soils and leading to compaction. And we'll even ask people, how much compaction did you or your neighbors do in these sheepish hands of, yeah, we know we did, trying to get things in. So, nutrient loss, planting, harvesting issues, and this increased use of drainage. People are trying to this is people these and we'll talk a little bit this about the end, adaptation and mitigation. People are starting to adapt to changing climate by doing this. They're adapting to the changing climate by draining more water off so that a field can be more productive in that standpoint. um, Also, another issue related to this is an assessment of what we call field work days. This is a NAS number or a NAS report each week on the crop production. USDA National Agricultural Statistics Services puts out a report each week during the growing season indicating a number of things. One of those is field work days. How many field work days were there where someone could get out in the field and do work? And oddly enough, I thought there was some more of this around, but and I think I've come up with a new project we need to do is assessing these on a regional basis. I borrowed this from a retired faculty member at Iowa State talking about the number of field work days in Iowa, and this was data for Northwest Iowa, basically comparing April, May, June precipitation versus the number of fieldwork days. And the overall assessment is that fieldwork days declines by two less fieldwork days for every extra inch of rain from April, May, and June. It's wetter, it's harder to get in the field, there's less time to get in the field. So this is part of that issue of the wetness that we're seeing here, reducing the ability for producers to get in and plant. And that's another adaptation that people are doing. Larger tractors, larger units are part of that issue of trying to be able to plant faster. And we can plant very quickly now if field conditions are appropriate. Um, I mentioned 2019, another example of that. These are indemnities from RMA for crop insurance due to losses that year. Your county up here, the counties that are in brown are over $10 million in indemnities because of crop losses that year. Most of it due to delayed planting, unplanted, or some other issues related to that. You were part of the one of the worst areas in other pockets in 2019 of wetness and delayed planting. Okay, jumping. Okay, I think we've touched on this number of the soils aspects related to excess precipitation. We're going to double back on precipitation on another part as we go along here. Another thing Dr. Blumenfeld brought up was increased temperature. that we are seeing warmer temperatures overall, especially Minnesota and up into the Northeast US and the Western US are all seeing increased temperatures. Um, but again, they are very seasonal. Winter is one of our warmer times. People in Minnesota may not want some of the warmer winters because of some of the downstream effects you get from that. And had some problems this year with some thin lake ice for people who want to be out on frozen lakes. That's one of the issues. But then there's some interesting things related to summer. We'll show you here in just a second. So this is again and here's that link I mentioned about. This is where you could also find the precipitation, that precipitation graphic. Breaking that down a little bit for what's happening in the way of temperatures. And this is specifically now for Stevens County. I showed that graphic before and the link for it. Now you can go, the previous one was by climate division, the West Central Climate Division. So it was a number of counties in West Central Minnesota. This is for Stevens County itself now. You can drill down to the county and get the same graphic for temperatures now. This is for summertime, June, July, and August. And this is average high temperatures in the upper left-hand side, average low temperatures in the lower right-hand side. Reiterating that thing that Dr. Blumenfeld talked about, that we are getting warmer in the summertime, but that warming in the summertime is being driven very heavily by overnight minimum temperatures, not as much by daytime high temperatures. And that has a different set of impacts for agriculture than we expect. We are warming, but warming in a different way that looks a little bit different. We'll talk about those as we go along here. We are seeing increased heat waves. Um, that Minnesota, down here on the lower right-hand side, and the central US are seeing increased numbers of heat waves, the trend from 1989 to 2018. This slide is taken from another document that I'll share with you towards the end called Climate Indicators for Agriculture. It was a USDA document that was put out this summer that reviewed about 19 different indicators of the changing climate, what's being impacted in agriculture. There's some direct ones like this, and then there are a few indirect ones we'll talk more about as we go along here. Now, other issues with temperature changes, while we may like some warming winters or some other issues, there are some other things related to temperature changes that impact what's happening in the way of agricultural production. It is extending our growing season. The warmer temperatures, warm overnight temperatures, is moving our spring freeze date earlier and our fall freeze date later. So we're extending our growing season. We'll talk more about that here in a second. It is changing our phenology. It's allowing crops to progress more quickly. In some cases, that's a good thing for northern areas. That can be a positive. In southern areas, you can say in the Corn Belt, you can be pushing crops too quickly through their phenological stages, and that can end up being leading to yield loss. And insects we'll touch on more as we go along here. Talking about phenology, and since we maybe have a few ag producers here, in showing a growing degree day tool, especially you folks in the northern part of the Corn Belt, the growing season sometimes is limited and you want to track where your corn production is compared to average. You can use this, and this is what this graphic looks like. It's not as live right now because we're not in the active part of the growing season, but it's a graphic that shows you where you are in the way of comparison to average, and then where you might make, if you have concerns about reaching maturity before the freeze date. Just pointing that out as a tool for people to share. Another thing that has happened because of um, these changes in temperature and precipitation, we're seeing our growing season, our growing region move. Corn and soybeans have rapidly moved from their kind of the traditional I states and up into your area, up into the Dakotas, and even southern Canada are becoming active uh, production areas for this. And especially up in the Dakotas, we have displaced some other crops. And even more concerning, we have taken some pasture or rangeland that was more of a natural setting. It's been replaced by row crop production now, and it's introduced some of those flashy issues that I mentioned with runoff from fields that would not have occurred if they had still been in pasture production. Mentioned also our frost-free season change. For home gardeners, this is a bit of an advantage, gives you a little bit longer growing season to take advantage of. But it is, we are lengthening our growing season, so there is some additional possibility to be able to take advantage of that. A lot of this is being driven by warmer nights. The unfortunate aspect in the spring for gardeners, this is not an issue, but for agricultural production, the earlier spring planting, to be able to take advantage of this may not exist because if you have wet soils, you may be past a freeze date, but you're still not able to get in there. I showed you that 2019 graphic earlier. I like telling the story from northwestern Ohio. They had their earliest last freeze on record, but they were still delayed planting because they were so wet. It's a kind of that odd conundrum we're dealing with. We're past the freeze date, but still not able to be able to plant. Okay, we're moving on now to. And let me pause there. Are there any questions anybody has up until this point? We're going to cover a few more issues and to kind of bring this around here. You can enter them in the chat, or you can speak up and ask at this point. Okay, why don't I jump ahead and we'll go ahead and then we can make sure to come back around here at the end. In addition to changes in temperature and precipitation, we're seeing an increased amount of moisture in the atmosphere. There's different ways of measuring this. We tend to measure it by dew point meteorologically because that's an absolute measurement. Relative humidity is problematic because it varies by temperature. But if you look at absolute measures of how much moisture is in the atmosphere, this is a graphic from a colleague of mine at Cornell. He and a student did. The gray circles indicate places where we have more moisture in the atmosphere, and the bigger the circle, the bigger the increase in moisture in the atmosphere. Now, what that means, it's also connected to the additional precipitation, but when you have very humid conditions, and if you think you've experienced this in the summertime, what are the times at night when you don't get cool? When doesn't it cool down very much at night? Those very warm, very humid periods in the summer when the temperatures just can't drop because when you have more moisture in the atmosphere, that limits your cooling capability. Um, so that is a potential issue. This also presents an issue for crops and it presents an issue for livestock, for people who deal with livestock, because that adds to livestock stress. Livestock can deal with some hotter temperatures during the daytime as long as they cool down. But if we don't cool down, that presents a different set of issues for livestock. Here's another graphic, another version of that. You can look at this. This is a guy from Iowa State who put some of this data together, and this is the change in dew point over time, averaged by year from 1950, 1948 on the left-hand side to the present on the right-hand side. And we don't have as many places where this kind of data is available. So this is from St. Cloud. I think it was the closest place I could come up with. But again, showing that average dew point, that average amount of moisture in the atmosphere is increasing over time. Okay, other livestock issues, to touch on some of the livestock issues. Less cooling at night creates additional stress on livestock, leads to reduced production, reduced gain, which is what we're trying to get out of livestock, leads to possible breeding issues. And there are occasions where we've seen, in extreme cases, mortality with livestock in these situations. This has been a bit more of a problem further west and places that typically aren't very humid, but it is a problem throughout all the upper Midwest. And it's tougher on humans working in those conditions too. One of the issues that is in that USDA document I referred to was looking at mortality, increased heat mortality on agricultural workers, and for all of us. These hot, humid conditions, when you don't cool down at night, makes it tough to be outside and doing any kind of work related in them. Now, the other issue when you have a lot of moisture in the atmosphere is disease, because when you have water on a plant, it increases the chance for disease. The more water and the longer it's on the plant, say longer dew is on the plant, it increases your chances for disease. And when you have wetter conditions, more humid conditions, more likely disease. Increased precipitation also adds to this because you get more splash from the ground, and sometimes some of the diseases are on the surface and they splash up on the crop. So we are seeing changes in disease issues. And I was asked this question today, somebody was talking about drought. Somebody mentioned drought earlier. Are there good things about drought? Well, sometimes the good things about drought is a reduced disease pressure. I did a talk a few years ago in Indiana and southern Indiana, and there was a big watermelon grower, and we were talking about disease there, and he said, yeah, that's why we like 2012. If you remember, 2012 was a major drought year. He said we had access to plenty of water, but it was great that year because it was so dry everywhere else. We had zero disease pressure. So these changes in disease are something we're seeing as we're going along. Additionally, changes in temperature and time of year are leading to shifts in insects, types of insects, and also how much more of them we have them. Because of changing temperatures, we're seeing geographic ranges moving northward. Winter die-offs, maybe you don't kill off as many insects in the winter, or they overwinter further north than they used to, so they can be reintroduced more easily. You get more spring emergence. And then because of the longer growing season, sometimes you get increased generations of them per year. Instead of having one, you maybe have two. Instead of two life cycles, you have three of them, are one of those issues. Another set of, not insect, but someone mentioned up was asynchronality. Another one of the issues that we're monitoring is changes in bees and pollination issues, because of mismatches and when bees are around and pollination kinds of issues. I didn't include that slide, but that's another issue that we're watching in the way of changes in agriculture. Yes, what are those? Those are, and I did not know about these. You've seen them probably. They come in your house. They're called the brown marmorated stink bugs. I don't think they stink that much, but apparently they do. But they are, for most row crop agriculture, they're not too much of an issue yet. But they tend to like some specialty crops. Uh, and out east, they have caused real problems with apples. Um, I think peppers are another issue. But if they become bad enough, they can go over to soybeans and some different things like that. So you're lucky you don't have them up there yet. We have them around our house, and our dog likes to find them and chew on them. So, and our postdoc we had at the hub for a few years did a lot of work on these invasive disease insect issues because of changes in climate. Then one other one we have here is issues with weeds. To complete the cycle here, changing weed distribution. Why is it? Well, changing climate. Certain weeds like different climates better. This is a graphic again from, this is a slide from that USDA document I mentioned earlier. Changes in the range of kudzu. For those of you not familiar with kudzu, kudzu was introduced about a century ago in the South as a ground cover, and it's incredibly effective ground cover. It's so effective, it covers up other things, and it's gradually working its way northward. Its range was here in 1971. It's worked its way further northward to 2017. It's one of many, many weeds that like certain parts of climate better. There's another issue with weeds and climate that is not so much climate itself, but one of the causes is carbon dioxide. This is a fairly well-known study that was done by a former USDA colleague. This is Canada thistle. On the left-hand side, this is current CO2 conditions as of, about 20 years ago, and then doubled CO2 conditions. And this is what the current herbicide rates look like on the right-hand side. So there are certain weeds that like carbon dioxide even more. Not only is they certain like certain parts of the climate, but they like more carbon dioxide, and they can be more competitive with other crops. That's an important point when we talk about carbon dioxide, is that plants do use carbon dioxide, but not all plants use carbon dioxide the same way. Certain plants can take more advantage of it. Other plants don't have quite as much of the ability to do that. Soybeans are ones that we think are able to take a better advantage of that, while corn is less effective at additional CO2 conditions. And then some other issues like timing of bud break in fruit trees. This is also part of that USDA document. Not as much of a problem up your way just yet, but it's been in some southern areas of part of our region where the winters are warming enough that they're breaking dormancy before our last freeze, and that's becoming a very serious issue for some of those areas. Okay, so just kind of a wrapping up some takeaways here. Um, you know, trying to bring the point home, climate change is already impacting us. Climate change is impacting agriculture already, and we're trying to encourage people to that they are adapting to that already, but we need to keep adapting to that further because especially if nothing else, and the most visible one that we can see, most people understand, is that loss of soil. We need to maintain that because that is our gateway to productivity. We have to have that soil, and the upper Midwest soils are ones that we are some of the most productive in the world. We don't want to lose that. The direct things we've talked about, temperature and precipitation, humidity should be included there too. But then there are these indirect issues related to soils, crop stresses, insect disease, and weeds that are issues that we continue to deal with. And then this last point, I realized I threw this in at the last minute, realizing I hadn't talked about this: adaptation versus mitigation. This is a big changing dynamic now because of the change in administration. We've always been encouraging adaptation. Change agriculture, change your practices to deal with changing conditions, and most agriculture does that. We have to push them additional in some ways, but most people will try to do that. The thing now is that adaptation is not sufficient, and adaptation is not going to get us all the way through the changes in agriculture. So we have to move to mitigation, greenhouse gas reductions, and some people brought those up early on. Greenhouse gas reductions. We know that agriculture is a greenhouse gas producer. Agriculture can also be a greenhouse gas sink. We can do things that remove carbon dioxide and other greenhouse gases and reduce emissions. We can't fix it all by ourselves. We can be part of that. And that is why there are a lot of discussions about how we will do this at the federal level. And I'm hoping that some things will happen, but we'll have to wait and see how that happens. Okay, I will pause there and